Okay, good morning, afternoon, or good evening, whatever time it is you're watching this. This is the second part of the June 2010 Foundation Calculator Practice revision paper. These are the main questions. Let's get cracking with them straight away. Okay, question 1, the graph-based question. This graph can be used to work out the cost in pence of a telephone call. The length of a call is 6 minutes. Use the graph to find out the cost of the call. So there is 6 minutes on the graph, and we would read this vertically upwards to the point at which it crosses, and then we can see along here that the answer is going to be 40 pence. The cost of another call is 30p. Use the graph to find the length of the call. So here, this time we would start here at 30 pence. And read across ways and then downwards. So that would be 4 minutes. Question 2. Write down a sensible metric unit for measuring the height of a mountain. I would say meters for this one. I don't think centimeters would be appropriate nor sensible. Write down a sensible metric unit for measuring the amount of water in a pond. That would be L or litres. Question 3. Nicola buys 2 milkshakes and 1 beef burger. Work out the total cost. Bearing in mind that this is a calculator paper, I'm deliberately not going to write anything down. I'm just going to do it all on the calculator. So she buys 2 milkshakes, so that's 90 plus 90, which is 180, and a beef burger, 245. I'm remembering to type in fact I will write down what I'm typing in. I'm writing down that. I'm not writing in 2.45, I'm keeping everything in pence. It's important to do that, otherwise you could end up giving away silly marks. So I then get an answer of 425, which is going to be £4.25. Ensure that when you do the addition on your calculator, you either do it all in pence, like I've done here, or all in pounds, in which case it would be 0.9, 0.9, add 2.45. That would then be in pounds. So either one, you've got to stick to pounds or pence with your calculator. Question 4. Here is a diagram of a solid cuboid. Write down the number of faces the cuboid has. So we've got front, back, left, right, top, bottom. So that's 6 faces. And you'll notice there that what I do is in some way I draw on or sketch on 3D shapes and put letters on and so on to help myself count things properly and don't forget things. Question 2, part 2 of 4, write down the number of edges of the cuboid. Okay, so we've got 1, 2, 3, 4. 4 at the front, 4 at the back, and then 1, 2, 3, 4 that join the front to the back. So there are 12 edges. Question 5. Here is a list of 8 numbers. From the list, write down a square number. Square numbers. 1 times 1, 2 times 2 is 4, 3 times 3 is 9. There you go. There's a square number. If you need to, for such questions, and you might get, what am I doing? 2 times 2, follow the pattern. If you need to, then don't be afraid to do this, because you might have bigger numbers involved and it might take you a bit longer to get it. The cube of 2. So the cube of 2 is 2 times 2 times 2. And I suppose a lot of people would say 6 immediately to that, but they forget that 2 lots of 2 is 4 and then 2 lots of that is 8. Such an easy one to get wrong. So many times do I see people say 2 to the power of 3 is 6. You just need to make sure you expand it and write it as 2 times 2 times 2 to avoid that mistake. Simplify 5m, take away 2m, 3m. Simplify 4c times 2d. When it's multiplying, I always just like to expand it so I can see the operations going on here. So it's 4 times c times 2 times d. I then rewrite it in order with the numbers all together. 4 times 2 times c times d. And therefore I can then see that it's going to be 8cd. Okay, next up. Simplify 3a plus 6b plus a, subtract 4b. I'm going to colour code and put shapes around my like terms, which are my a's. I'm going to use a different colour and different shape for my other terms that I'm collecting together. So I've got 3a plus a, and I've been particularly accurate here to make sure I include the operator that goes with the term, the plus, or the subtract symbol. I then have plus 6b, take away 4b. From here, I can see that I have 4a plus 2b. Concert tickets. Mr. Brown buys 2 adult tickets and some child tickets. The total cost is £39.50. Work out how many child tickets he buys. There's 2 ways of doing this: trial and improvement, or kind of an algebraic way of doing things. We first of all know that he has bought 2 of those ones. So what we've got is 2 times £7.50, so on a calculator that's £15. What we now need to do is subtract that from the total cost. Not going to waste time there, I'm going to quickly plug into a calculator. 39.5 take away 15 is 24.50. How many child tickets does he buy? So it's how many is what we're after. So we need to find out how many lots of the £3.50 go into the £24.50. Plugging that into a calculator gives us 7. Don't write £7 or anything else, just 7. It's the number of tickets, number of child tickets. Question 8. A small box measures 6 by 10 by 5. Carton measures 30 by 30 by 40. And I know the question before I even read it. It's going to be something like how many small ones fit into the big one. The carton is completely filled with small boxes. Work out the number of boxes in the carton. So what we're saying here, if it's saying it's completely filled with, we're assuming there's no gaps, there's nothing left over. So it's basically how many of that go into the larger one. The volume of the smaller one is 6 times 10 times 5, which is 60 times 5, which is 300 cubic centimetres. The larger carton is 30 times 30 times 40. I'm going to plug it into a calculator to avoid making any silly mistakes. And that is that was meant to be a cube there, is 36,000 cubic centimetres. What I need to do is do 36,000 divided by 300. Because we're basically saying how the total cubic capacity inside here is 36,000 and the total cubic capacity of this is 300. If we know it's completely full, then it's basically jamming those ones into the big one with no gaps. The answer to this will be 121 smaller boxes. Okay, so that is how we get there, by finding the volume, which is width times length times height. Sometimes people will have different letters, like the depth times width times length, in terms of calculating volume of a cuboid, but it's going to be 3 dimensions multiplied together. Okay, last couple of questions here. Work out the value of, and we've seen these before where you've got to plug things into your calculator correctly, 6.5 squared divided by 7.3 take away 2.54. I suggest you do the 6.5 squared first and write that down, which is 42.25. On your calculator, once you've got your 42.5, I would then take your 42.5, divide that, and then open the brackets, 7.3 subtract 2.54. Here's a little warning. This is what you don't want to do. Do not do this. Do not just plug in that into your calculator. 6.5 squared divided by 7.3 take away 2.54. What this will do, your calculator will work just like BibMaths is supposed to. Your calculator won't do this wrong, you will be inputting it wrong. It will do the indices first, then it will do the divide, and then it will do the take away. So it will do effectively what that would look like is this. 6.5 squared divided by 7.3 and then subtract 2.54. But that is not what this is here. So what you've got to do is you've got to make sure you do this one here. You find your 6.5 squared and then divide it by all of this together. Okay, that means you're doing this bit underneath here. Whenever you see like calculations above or below the line for a fraction, that means you're kind of imagining that bracket should be around it. 7.3 take away 2.54, and you should, it says right, you must give your answer as a decimal, and I've got on my calculator 8.876 to 3 decimal places. If you've got a newer calculator and it gives this to you as a fraction, you do have a little button which is like an S to D button, which my class always find humorous in how I say it. It's not an STD button, it's an S to D button. Okay, question 10. The diagram shows the positions of 2 ships, A and B. Ali says the bearing of ship B from ship A is 040 degrees. This topic is bearings. From the bearing of ship B from ship A, so we're starting here, is 040. Ali is wrong, explain why. A really easy one here. There are 3 basic rules of bearings. Always 3 digits. Always start from north and clockwise. Always move clockwise. I'm talking about bearings. That must means you go that way around. Think about the hands of a clock. So in this example here, Ali has gone from north but gone anti-clockwise. So your answer here is saying she has gone anti-clockwise. That would be enough for 1 mark. Work out the bearing of ship A from ship B. So that's going from A going of ship A from ship B. That means we're starting at B and going there. So assuming she's measured this 40 degrees accurately, what we can say is that if we continue that down there, that angle there is going to be 180, take away 40, which will give us 140 degrees. And because this north line is parallel with this north line, that allows us to say that this angle here will also be 140 degrees. Okay, so this angle here will be 140. It's the same as these two north lines, which are both parallel to each other, because this line here continues all the way down here in a straight line if you imagine it. And we've got one more question. Write as a power of 7, 7 to the power of 6 times 7 to the power of 2. If you know this instantly, you can quickly write down 7 to the power of 8 and everything's fine. Common mistake, 7 to the power of 12 is not the answer. Let's see why that is the case. 7 to the power of 6 can be written like this. That's 7 to the power of 6 multiplied by 7 to the power of 2. Hopefully you can see there that what we've got altogether is 7 to the power of 8. That's why this answer is what it is. Likewise, we can do the same with division. 7 to the power of 9 divided by 7 to the power of 5. Now, if you know this, you could quickly go 7 to the power of 4, but to help understand, you've got 7 times 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 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we've got 7 to the power of 5, all divided by 7 to the power of 5. Okay, so that's 7 to the power of 9 divided by 7 to the power of 5. What we can do here is we can cancel one down on the top and one on the bottom each time. Why we can do this? Because 7 goes into 7 once. So anything times by 1 doesn't change anything. We can do this top and bottom each time by cancelling down. What does this leave us with? 7 to the power of 4. Okay, and that concludes the workings and solutions for June 2010.